This problem is a great example or application problem for systems of linear equations. We have a Broadway theater that holds, it has 500 seats, and it's divided into main, orchestra, main, and balcony seating. Orchestra seats sell for $50, the main seats sell for $40, the balcony seats sell for $25. If all the seats are sold, then the gross revenue of the theater is $18,450. So let's look at those first, that information first. I'm going to let X represent the number of orchestra seats. I'm going to let Y be the number of main seats. And I'm going to let Z be the number of balcony seats. So given the information we've read so far, I know that the number, when I add all of these variables together, the number of orchestra seats, the number of main seats, the number of balcony seats, when I add those together, I get X plus Y plus Z. That gives me a total of 500. That's what that first sentence gives me. The second sentence tells me that the orchestra seats sell for $50, the main seats sell for $40, and the balcony seats sell for $25. So if I multiply $50 times the number of orchestra seats, then that's going to tell me how much revenue I'll get for selling those seats. So the revenue I get for selling orchestra seats will be 50 times X. Add that to the revenue you get when you sell main seats. It's going to be $50 for each. No, I was right. It's going to be $40 for each main seat. So the number of main seats is Y. That gives me 40 times Y. So that's the total revenue so far for selling orchestra seats as well as main seats, assuming that all of the seats were sold. And then lastly, if I want to get the revenue for the balcony seats, they're $25 each. So it's going to be 25 times the number of seats in the balcony. And that gives me, they say, a gross revenue of $18,450. The last piece of this says, if all the main and balcony seats are sold, but only half of the orchestra seats are sold, then it gives us a gross revenue of $15,950. So the fact that all the main seats and balcony seats are sold, that's going to be $40 for each main seat times the number of main seats, which gives me 40Y. That's the total revenue for main seats. Balcony seats are $25 each. So if I take $25 and multiply times the number of balcony seats, that gives me 25Z for the revenue there. But then it says only half of the orchestra seats are sold. Well, that means I need to take the revenue that I get for orchestra seats and divide it by 2, or multiply it times 1/2. So $50 for each orchestra seat. So $50 times X. If I take half of that, it's going to give me 25X. That revenue, adding all of these together, should be $15,950. Notice we have a system of 3 equations with 3 variables. And we know how to solve this. We're going to solve this using matrices. So I've written this in matrix form, and in the top left corner we have a 1. Remember, we want 1 on the diagonal and zeros below the diagonal. So we have a 1 up in the top left corner, so we're good there. We now need to get a 0 or zeros below that first 1. To get a 0 in the second row, where that 50 is, I'm going to multiply negative 50 times row 1 and add it to row 2. That gives me a negative 50 plus 50, which gives me a 0. Negative 50 plus 40 gives me a negative 10. Negative 50 plus 25 gives me a negative 25. Negative 50 times 500 gives me 12,500. When I add that to 18,450, that gives me a negative 65 or 6,550. My top row stays the same. I'm going to do the same thing or something similar to get a 0 in the third column. The first column, third row. That's going to be a negative 25 this time times row 1 plus row 3. Negative 25 plus 25 gives me 0. Negative 25 plus 40 gives me 15. A negative 25 plus 25 gives me 0. A negative 25 times 500 gives me a negative 12,500. When I add that to 15,950, that gives me 3,450. Moving along, now we need to get a 1 where the negative 10 is in the second row. To do that, I'm going to divide row 2 by a negative 10, which is the same as multiplying times negative 1 over 10. Row 1 stays the same. Dividing row 2 by 10, I get 0, I get 1, by negative 10 I should say, 2.5, and 655. Row 3 stays the same. I now need to get a 1 where the 15 is. To do that, I'm going to multiply a negative 15 times row 2 and add that to row 3. In doing that, my first row stays the same. My second row stays the same. My third row, though, now becomes negative 15 times 0 plus 0 gives me 0. Negative 15 times 1 plus 15 gives me 0. Negative 15 times 2.5 gives me a negative 37.5. And what I did was I added that to 0 and it gave me a negative 37.5. And then a negative 15 times 655 gives me a negative 9,825. When I add that to 3,450, I get a negative 6,375. My next step is to get a 1 in that last position down here with that negative 37. To do that, I'm going to divide row 3 by a negative 37.5. That has the same effect as multiplying by a negative 1 over 37.5. My row 1 stays the same. My row 2 stays the same. My row 3 now becomes 0, 0. When I divide negative 3.37.5 by negative 37.5, I get 1. And then when I divide a negative 37.5 into a negative 6,375, I get 170. We now have the matrix in the form that we wanted. So I know that 1x plus 1y plus 1z is equal to 500. I know that 1y plus 2.5z is equal to 655. And I know that z is equal to 170. So we have 1. We know that z represents the number of balcony seats. So we know that there are 170 balcony seats. We can plug that in here. And so we end up with y plus 2.5 times 170. So we end up with y plus 425 equals 655. And when I subtract 425 from 655, I end up with y is equal to 230. So we have two variables now that we can plug in. And when I add, so I know that x plus 230 plus 170 equals 500. So if I subtract 230 and 170 from 500, that gives me x is equal to 100. X represents the number of orchestra seats. Y represents the number of main seats. And so these are the number of each kind of seat that you have in the theater.